Okay, in this video we're going to talk about not the odd degrees, but the even degrees. Okay, what happens if I have an even degree polynomial? And so what we're going to see here, similar to last time, you have right here a graph of y equals x squared, just your simple parabola, right? But what might be interesting, I think, to me, is the fact that if I go here and I graph x to the fourth, man, that looks like a parabola too, doesn't it? And if I go graph y equals x to the sixth and y equals x to the eighth, I graph them all at the same time, they all look like parabolas. They either go up and up on the ends, right, like this. And stuff that happens in the middle, just like last time, the stuff that happens in the middle, we don't really care about at this point in time. We're determining in behavior what happens out here as x goes farther and farther to the left or farther and farther to the right, okay? Now, what you'll notice here, same pattern, okay, so I'm going to make this a much shorter video. If you watch the odd behavior, then now we're talking about the even behavior, okay? You're going to see that the same thing occurs here, okay? X squared, x to the fourth, x to the sixth, they all act the same, and they all have a positive leading coefficient. That means that the highest power of x is positive, okay? And then whenever that happens, I don't know what happens in the middle here. That's determined by all the stuff that's off in the end, not the x to the sixth, but the x to the fourth, x squared, and so on and so forth. But what happens on the end is, over here, the y-coordinate goes upward, that's positive infinity, as the x-coordinate goes to the left, that's negative infinity. And on the right-hand side, the y-coordinate goes up, that's positive infinity, as x goes to the right, that's positive infinity. Okay, that's our way of saying that the graphs for even powers go up and up whenever I have a positive first value. Okay, now, just to show you what happens, okay, if I add stuff in, the x to the fourth determines the shape on the ends, the stuff afterward determines what happens in the middle, which I'm really not interested at this point in time. That's what the table's for. If I graph these though, okay, so notice there's your kind of W shape, right? And then the x to the sixth, I don't even know what that's going to look like. I hope it shows up. You know, that was weird, right? Okay, here's your x to the sixth. All right, so it kind of looks like a weird off-centered parabola, right? Similar to that, but what we're interested in is what happens at the end, okay? Now that's all with the leading coefficient that's positive, so let's go take a look at what happens whenever it's negative. If I insert some negative signs here, some negative signs here, some negative signs here, a negative sign here, okay? We won't graph them all at once. Let's graph the x squared. Oh, weird, look at that, flips it upside down. This flips it upside down. There's the negative x to the sixth coming up. There it goes. Flips it upside down, kind of like you expect, just like we've been working on with parabolas. So it turns out that we have the same pattern, okay? If I go through and I graph the negative x to the sixth one, the only thing that I've changed here is I changed that very first value to a negative. Here comes our off-centered parabola, all weird, right? But now this time it's upside down, okay? And what we're interested in is not what happens in the middle, but what happens out here. And so we get something that looks like this. The y-coordinate goes down as x goes to the left. The y-coordinate goes down to negative infinity as x goes to the left, which is negative infinity. And on the right-hand side, the y-coordinate goes down, that's negative infinity, as the x-coordinate goes to the right, that's positive infinity. And so hopefully that makes sense. Really, this statement down here, I'm going to put on the homework, but it's going to be very quick. What I'm really more interested in is, do you know the basic shape of a graph? I mean, if I gave you a graph that looks like this, could you tell me that that's got to be like x cubed or x to the fifth or x to the seventh? And could you tell me that the first number has to be positive? Or if I give you a graph that looks like this, could you tell me that must be either x squared or x to the fourth or x to the sixth or x to the eighth? It's got to be an even polynomial, an even degree, and it's got to have a negative first value because it's upside down. If you can do that, then that's really what I'm most interested in at this point in time. And in order to actually graph it, that's when we use that table feature like we did in the very first video.